Hi, my name is Rachel. I'm a software engineer on Firebase security roles.
And I'm Sebastian, and I work on Firestore. Rachel, do you still remember what you did on May 25th?
How could I forget? That was the day I was flooded with emails from every website that I had ever signed up for. They all wanted to tell me about their brand new privacy policy. I looked at those fines, and I also wondered if that experimental app I created in 2009 was about to get me in big trouble.
On May 25th, the General Data Protection Regulations took effect. By itself, this regulation affects anyone that stores or processes data from users in the European Union. The goal of giving users transparency and control over their personal data is, however, not a new one. User privacy is larger than any one piece of legislation. And even before May 25th, different regulations around user privacy apply to users in most countries. Rachel and I believe that everyone's privacy should be respected, no matter what geographic region they happen to be from. We are here today to show you how you can use Firebase to treat data privacy as a first-class citizen, and how you can design serverless software with user data protection in mind from the very beginning. Since neither of us are lawyers, we are not going to give legal advice. We're going to stick to what we know best as engineers. We will tell you what we personally think the key steps are when you're building an app that puts user privacy first.
When you're designing for serverless architecture, you're worried about things like, which components should I use? What features do they offer? How will they interact with each other? And how well will each component scale? By contrast, when you're designing for privacy, you're worried about things like, how will I make sure that my data is securely stored? How will I make sure that my users understand the data that I need to save? And how will I remove the data when I no longer use it? It certainly doesn't feel like there's a lot of overlap between these two. And some people have even suggested that serverless architecture and data privacy feel like they contradict each other.
Seems like Rachel is reading my mind. But let's be honest, even though I deeply care about user privacy, I am not willing to give up serverless development just yet. I don't want to go back to the days of installing, maintaining, and upgrading my very own MySQL instance just so that my Android app can receive a single push notification. Fortunately, serverless design patterns and user privacy can often go hand in hand. At Firebase, we are proud to offer products and tools that help you respect your users' data, not despite, but because of our serverless offerings. Let's dive in and take a look at a few examples.
We'll start by showing you how you can reduce the data that you store and how you can use cloud functions to help you manage that data. We'll show you examples of user data deletion and more advanced features such as user data export. Sebastian and I will reiterate the importance of writing robust security rules to limit access to your data and to describe data ownership. And we'll talk about how you can notify your users about the data that you're collecting, including advanced use cases like activity logs. We'll cover the storage retention for our backend products and show you patterns for storing privacy preferences.
Rachel and I want you to design your apps for privacy from the very first line of code. The easiest way to do this is, of course, to not store any data.
Sebastian, any data?
OK, let's stay realistic and only save the data that we need. For example, let's say we have an app and we want to make sure that our users are European citizens over 18. Instead of storing the user's full birthday and country of birth, we only need to store whether they meet our two criteria. As you design your apps, think about what data you need for them to function and what the amount of time is that you need to store this data for.
Oh my God. OK. Not everyone is starting with a brand new project. If you have an existing project, you're not out of luck. I recently improved the user privacy features for our open source sample app, FriendlyPics. As we mentioned this morning, FriendlyPics is an app that lets users upload photos and offers social features such as commenting and following friends. When I looked at how we treat user data in FriendlyPix, I found that data was used for one of the app's core functions. First, the app stores user profile or account information. Next, FriendlyPix stores the pictures that users are uploading. And finally, FriendlyPix saves those social interactions with the pictures. These are things like likes and comments. So whether you're writing a new app or you'd like to improve data privacy of an established app, the first step to managing privacy is to get a clear idea of the data that your app needs, which features are using that data, and how long you need to keep it. In general, we like the principle that you can keep track of the data that you store, keep only the data that you need, and only keep it for as long as you need it.
After all, you probably have to delete this data again one day. To me, offering users the ability to delete their data really is an important pillar of user privacy. You should delete user data not only when a user removes their account, but also when you no longer need a specific set of data for your app to function. If you design your app with user privacy in mind, deleting user data can be pretty simple with Firebase. The asynchronous nature of most deletes makes deleting user data a great use case for Google Cloud Functions, a service that should already be one of the primary tools in your serverless tool belt.
Ooh, I love a good function.
While deletion is often triggered by explicit action in your app, as in this example of a user deleting their post, remember that you ultimately don't control the requests that come from your client. You don't want to rely solely on your customers to delete their own data. To remove data that is no longer needed, you can create a cloud function that cleans up unneeded items. Sometimes it's even obvious what data is obsolete. When a user removes a picture from FriendlyPix, we delete all comments and likes. For other use cases, this may not be as apparent. If your app has functionality that only temporarily needs some of its data, you may want to regularly delete the unused portions as well. An example of this is a high score list, in which you only need to keep the highest scores and not the complete history. You can find an article that explains how to set up a cron job that triggers a cloud function in the Firebase Summit schedule. FriendlyPix really is a good model here. It doesn't keep any data longer than 30 days and uses a cloud function to periodically delete older data.
You'll also want to ensure that you no longer keep data for users that delete their accounts. If you're using Firebase authentication, you can call the delete API of Firebase user object to delete an account. Calling delete will not, however, remove user data from other Firebase products, such as Firestore. But if you're going serverless, that cleanup is a great use case for cloud functions.
Oh, nice. Yay.
The function could either be triggered by the authentication delete event, or if you're not using Firebase authentication. If you're not using Firebase authentication, you can trigger the function via an HTTP request. We've done some of the work to get you started by publishing a general-purpose account deletion function that you can tune to work with your own data model. There's a link to it in the Firebase Summit schedule, but let's walk through it quickly. First, this is my function. It lives in index.js. In my client code, when a user clicks the delete account button, I delete the user in Firebase authentication, and that triggers my function to run. But the function is generalized. To make it work specifically for my app, I've added a JSON file in the functions folder called userprivacy.json. This file allows me to define the paths that need to be removed when a user deletes their account. I can add paths for all the services that I use, such as Firestore, real-time database, and storage. And I'm using a variable for the parts of the path that will be replaced with the user ID. When the function is triggered, I get the UID from the event.data object. And because I want to remove data from Firestore, the real-time database, and storage, I call 3 helper functions, and I pass the UID to each of them. If you're not using one of these services, you can exclude those unused functions so you don't have dead code. Each of the helper functions share the same basic structure. Let's look at the function that clears data from the real-time database as an example. First, we fetch the relevant paths defined in our JSON file. Then we iterate through each one and remove the data at that path. And when each iteration returns, we return control to the top-level function.
You may also want to offer your users data portability. Providing users a copy of their data in a well-known and machine-readable format allows them to transfer their data between different service providers. We've released another cloud function called export data that can help you with this. We also link to this function in the Firebase Summit schedule. This export data function is triggered by an HTTP request that you can make when a user requests a copy of their data. It calls 3 helper functions that perform the export for each product. The helper functions, in this case, the one for the real-time database, use the same user privacy.json file that Rachel just showed you. You can use the same path as before, but you can also provide a separate configuration. The helper functions iterate through the schema and export a JSON file with the user's data. When each helper function has finished, this JSON file is uploaded to a cloud storage bucket. It's incredibly important that the exported data is only accessible by the user whose data you exported. We accomplish this by using Firebase security rules. Since we upload the exported data to a location that includes the user's user ID, we can create a security rule that makes this data only accessible to that user. Remember that it is essential that you audit your security rules if you're storing user data with Firebase. If you deny access in one rules expression, but grant access in another, access is granted. Make sure that you understand that rules are always ORed together.
If you have a more complicated data model for your app that can't be expressed as a list of wildcarded paths like this, I suggest that you maintain a list of location for each user's data. And you can use that list as the input for a custom cloud function that, similar to our sample functions here, iterate through the paths and either delete or copy the data one by one. If you keep user data portability in mind when you're designing your data model, then deleting and exporting data can be as simple as configuring and deploying a generalized function. Serverless development makes respecting user privacy easier than ever. With Cloud Functions for Firebase, you can manage your users' data without building out expensive infrastructure. And we've published a guide for clearing and exporting user data. There's a link to it in the Firebase Summit schedule.
Let's talk about data security for a moment. Let's recall how security is handled in a traditional backend application. In a, let's call it, server-full application, there's a client, a storage layer, and an application layer. The application layer is often used to enforce security and access controls. If a client sends a malicious request, the application layer can drop the request. In serverless systems, the application layer has been removed. The client connects directly to the storage layer. So where should a serverless system enforce access controls? In Firebase, access controls are enforced right at the storage layer. We validate every incoming request against the security rules that you configured. Security rules are your first line of defense in creating secure Firebase apps. Secure apps really are an essential part of treating your users' data well, and correctly configuring security rules is an important step in preventing unauthorized data access.
We heard that security rules can be confusing and even intimidating to write. That's why we've invested in new features to make security rules easier and more approachable. Because rules are so important for user privacy, we're going to review some of the highlights of how we're trying to help you write security rules. First, before you deploy rules, you should test them using security rules simulators in the web console. These simulators let you test different kinds of requests so you can verify that what you want to succeed does succeed, and those requests that you want to be blocked are blocked. Simulators are available in the Rules tab for Firestore, the real-time database, and storage. But the simulators only help you get your rules right as you're writing them. Say yesterday, Sebastian wrote great security rules, and then today I came along and improved them, and I accidentally granted access that I shouldn't have. To make sure that you have confidence in your rules going forward, you can now also create rules. You can also create unit tests that use the new local security rules emulators for Firestore and the real-time database. These tests can even be added to your existing continuous integration workflow, and there's a link to get you started in the Summit app.
The security rules we've shown you today describe a schema for your data and spell out invariants for your backend. They allow you to limit not only who can access data, but can also enforce how the data itself relates to one another. Please remember to never trust the data that you get from your client apps. Since you no longer have an application layer, security rules are the best way to enforce access controls. Use the simulator we offer in the web console to help you write and verify your security rules. And use the new security rules emulator to write automated tests around these rules.
Now you're ready to inform your users about what data will be collected. At Firebase, we've published our data retention policy on our website, and you can include this to inform your users about your data collection. The Firebase data privacy terms explain what kind of data each Firebase product collects, how long it's retained, and how you can delete that data. We've also just released a white paper that explains what happens inside Google Cloud when you invoke an API to delete data. You can find a link to our terms and to the white paper in the Firebase Summit schedule.
When you read our data privacy terms, you may see that some Firebase products, like cloud messaging or A/B testing, have the ability to identify individual devices. This allows us to message or change the experience for only a subset of your users. This device-level identification is done via Firebase instance IDs. Because they are so important, let's quickly go over them. If you incorporate a Firebase product that uses instance IDs, Firebase automatically assigns a unique instance ID to every app installation. If you install two different Firebase apps, they each have a different instance ID. If you install the same app on two different devices, say an iPhone and an iPad, we will also assign two different instance IDs. On the other hand, when a user restarts the same app on the same device, Firebase keeps the same instance ID. That's how we can send a notification even to apps that are closed. While instance ID data is generally not meant to be personally identifying, it can potentially be linked to any personal profile data that you store in other products. If you want to allow your users to opt out of this type of data collection, you can disable instance ID generation. We have also added dedicated APIs to our admin SDKs that lets you delete the instance IDs themselves. Remember that it is your responsibility as a developer to invoke these APIs when a user requests account deletion. For Firebase products that key data by instance ID, the time it takes to remove this data varies by product, and information about this is available in our privacy terms.
It's important to understand both the way that your app is using data and the Firebase terms when you're ready to inform your users about your own privacy. The first thing to know is that deleting data from our backend systems does not immediately delete all copies of the data from our system. Some of it's kept temporarily in backups and caches. With all this in mind, you're ready to inform your users about your own privacy terms. I recently added a notice to friendly pics to let users know what kind of data is being saved and what features that data supports. This notice gives them the choice if they'd like me to use the data or not. Features are only enabled for the users that actively check to let me save the data. For example, if a user didn't want me to share their social data, I remove the ability to, sorry, I said I would share, and I would never do that if they didn't want to share their social data. Then I remove the ability to add comments. And if a user doesn't want us to store any data at all, FriendlyPick still offers a good read-only mode.
Depending on how much of your app's functionality is handled by our backends, you may also need to persist the user's privacy settings in Firestore or in the real-time database. When you consider structuring this data, look at what privacy controls the backend needs. You'll likely want to make sure that these settings are stored in a place where you can prevent unauthorized access. For example, if your user's profile information is public, you probably want different access restrictions for these privacy-related settings. To achieve this, you can use a layout such as the one here that contains a private profile section in addition to a public one. Alternatively, you could store the privacy preferences in a separate section of the database nested under the user's user ID, as we did in this example.
You'll also want to build a way for users to update their privacy settings. This allows you to add new features over time or to modify existing features. It's one thing, however, to let users update their privacy preferences, and it's another thing to figure out what to do with that existing data when their preferences change. For example, say a user grants consent for me to save their photos and then changes their mind. Should we delete the existing photos, or should we only delete them when a user deletes their entire account? This balance between user expectations and user privacy is different in every app. In FriendlyPics, we decided to keep the existing pictures, even if a user doesn't want us to store new pictures. And a user can still remove existing photos individually, or when they delete their account, we'll delete them all.
As users change their consent settings, you may also want to keep a record of these changes in an activity log. An activity log allows you to share privacy-related changes with your users and gives them the ability to monitor changes to their account. If you're storing your privacy settings in Firestore or in the real-time database, this is another good use case for Cloud Functions. With Cloud Functions, Firebase can automatically maintain an activity log for you. It's straightforward to create a small function that is triggered every time a user's privacy settings change, and which then copies these new settings to an append-only storage location. Here's an example of an activity logger that listens to changes in the privacy collection of Firestore and adds entries to a dedicated activity log section. If you want to make sure that this activity log is append-only and cannot be modified, you can use security rules to prevent any changes to existing information. For example, if your activity log uses a Firestore collection for each user and a document for each time a user changes their settings, you can use a rule like this, which allows document curation but doesn't allow updates or deletes to existing data. We've created a guide to storing and using privacy settings in Firebase that explains how to automatically maintain activity logs. As always, you can find a link to this guide in the Firebase Summit schedule.
Building privacy features like secure access controls, data portability, and data cleanup can be within easy reach of every developer on our serverless platform. Many of the privacy features that we've pointed to today can be directly deployed to Cloud Functions, and we've shown you how you can lock down your data with Firebase security rules. We hope that the tools and technologies that we've highlighted today can help you turn user privacy into one of the easiest features you build in your app.
GDPR is not the first and will certainly not be the last piece of legislation that changes how we look at user data. The ever-growing list of user privacy regulations makes touching any kind of data seem really daunting. But let us all take a step back and let's instead focus on doing the right thing for our users. If we treat our users' data with respect, if we make sure data retention policies are easy to understand, if we limit the amount of data that we handle, and if we offer our users the ability to make meaningful decisions about the data they lend to us, then we'll likely be in a good place, no matter what privacy regulations the future may bring. Come find us later at the Ask Firebase station. We'd love to talk to you about how you can be responsible with your users' privacy. Remember that we can't help you as lawyers, but we can be better together as friends.